Okay, time for NBT5. It is multiplication. In fourth grade, we have to do single digit by 4-digit and 2-digit by 2-digit. Only reason I have up here a 2-digit by 1-digit is just to get that simplicity factor. The kids can learn the process of which multiplication takes place. They've had it before, but let's just give them a quick reminder, as well as us for teachers, like, hey, what's the process again? This is the natural way. I always teach the algorithm you and I know with just the regular multiplication, the old math, I guess. It's good to know, and the kids are supposed to know it. It is part of our standard, so I will teach them this. So that way you guys should know, but just in case, 2 times 8 is 16, and 2 times 2 is 4, plus 1 is 5. That's the regular algorithm we've learned since we were in high school, when we were kids, and everything else. But now there's this new way. It's called an area model. There might be other names for it. Basically, it's place value multiplication. You're going to hear this over and over again. Place value, place value, place value, place value. To create that understanding. What was that one again? Why did you do that? Why did you go to the ones place, now the tens place? And that just gets further driven home when you get into multiple digits and them doing it. Like, why am I going over there and stuff? Let's teach them the why. I split it up. 28 is 20 plus 8. We have 8 ones, and we've got 2 tens, or 20. And then 2 is just the 2. So we split it up into our place values. Now we can do it. What is 2 times 2? We put the 4. And then what's 2 times 0? A 0. Eventually, the kids will start saying this, where you just steal the 0 or bring the 0 down. That's an okay concept as long as they understand it's actually 2 times 0, and it's just getting to that 0. So make sure you drive that home at the beginning. Eventually, we all like to be a little faster and more concise, so they will start stealing the 0. Just keep reminding them that's what we're actually doing. 2 times 8 is 16, and then you take these two separate numbers and add them together to get 56. An extra step you can add to make it either harder or even better with conceptual understanding is have them write what actually took place here. How did we get to 40? We did 2 times 20. How did we get 16? We did 2 times 8. By adding that one extra step, you are further putting in what's happening in that, as well as you can break the question apart. It's not just 2 times 28, it's actually 2 times 20 and 2 times 8, and getting those aspects. Okay, this problem's a little bit bigger. Again, it's the actual standard for fourth grade. We got the 4-digit by the 1-digit. I left the square blank so you can watch me put them in there. Where do these numbers go and how do I do it? The 4 is easy. I always like putting it on the side. I don't know. That's just my preference. It doesn't necessarily matter. You can put it on the bottom. You can put it on this. But try and keep it the same for your class so you're not just constantly moving the numbers around. This is a tool, not a trick. So let's put the 4 over here. Again, you could put it anywhere you want, but let's just keep it the same, whichever one you choose. And then we're just going to split this up into its place value. So we have a 6. Split. We have a 7, but that's not just 7. It's 7D, and we have to teach them that and further drive home that place value. We have a 5, but it's a 500. And we have a 4, but it's a 4,000. I like to put this up here. It's not necessary, but putting this plus, so they're understanding this is actually one number. We're just splitting it apart for our own ease. Let's get into multiplying it. We are doing 4 times 4, 16. And then 4 times 0, 4 times 0, 4 times 0. Going to the next one. 4 times 5 is 20. 4 times 0, 4 times 0. 4 times 7 is 28. And 4 times 0. 4 times 6 is 48. And then we're on the side here. We're just going to add all these numbers up. It is up to you on how you have your kids do that. Whether it is one number at a time, 2 numbers at a time, all of them. That's completely up to you. Once you've added them up, you'll get the answer. 3, 8, and 1. Boom. They're going to understand that. Again, adding that extra little part is super good for them. We're doing 4 times 4,000. We're doing 4 times 500. We're doing 4 times 70. And we're doing 4 times 6. Whoops, made a mistake. It happens. It's okay. 4 times 6 is 24. And then again, that extra bottom part would be 6 times 4. or 4 times 6 to make it easy. And then you just add them all up here on the side. You'd write 16,000. You'd write 2,280 and 24, and just have them add them all up. And then you teach them that regular algorithm way. I almost make my kids do this year round, and then this is the supplement. That's a little backwards from other teachers. I just believe that this place value understanding will make them naturally move to this because it's so much faster. I prefer the natural move opposed to me forcing them to go to the more algorithmic way. So you guys talk about that and how you would do it. Let's go 2-digit by 2-digit. The other aspect to the standard is understanding how to multiply a double digit by a double digit. I didn't put it in the square just so I can show you. Again, you're going to split it up. We have a 30 and a 7 split. And now it's different on this one. We have a 20 and a 9 split. So there'll be 4 different squares because we're doing them all. The way I like to teach this is this one touches all those lines. So it'll always be 20 times 20 times. This one always touches. So it'll always be times 30 times 30. This one always touches, so it'll be times 7 times 7. And this one always touches, 9 times 30, 9 times 7. And so you kind of get that format of how do we know what we're multiplying. Once we get to this part, I always force them to make these equations so that I can visualize what that they are messing up with. Are they not understanding how to multiply, or are they not understanding where to multiply and which numbers are being multiplied? So that's an aspect that I put in there. Now we just do our normal thing that we had just learned. 2 times 3 is 6. And then we can steal the zeros, but it's 2 times 0. It's 3 times 0. It'd be 600. We stole the zeros. 2 times 7 is 14. There are no zeros. There's a 0. We steal it, or it's 7 times 0. 9 times 3 is 27. Steal that 0. And 9 times 7 is 56. There are no zeros. There are no zeros. And then we just add those over here to the side, and we would get our answer. That is NBT5. Make sure you use them both. The standard is teaching them both, but again, I like to naturally get them to understand this enough to want to go to the speedier method.